C-R-A-C-K-I-N-G. What is cracking? The breakdown of larger alkanes into smaller alkenes and alkanes. This is cracking, okay? First of all, the definition is very important, in which you're going to pick up two things out of that definition: the breakdown of the larger alkanes, okay, into smaller alkenes and alkanes. This is very important, which you need to keep in your mind. Moving on to the examples, the examiner will pick up one example which is a very crucial one, and we'll talk about that one after. 8H18, this is an alkane, okay? So if I crack it down into a small alkane and alkene, we'll choose, okay? So the cracking can be, if I take C4H8, is this an alkane alkene? And C4H10, this is an alkene and this is an alkane. But it's not necessary that you break it down in that way. You can break it down in a different way. For example, it can be C5H12 plus C3H6. Keep in mind the number of carbon and hydrogen on the reactant side should be the same as the total of product side. Now you can see how many carbons are there. 8. How many carbons do you see here? 8. How many carbons do you see here? 8. How many hydrogens do you see? 4 and 8 and 10, 18. 18 are there, and 6 and 12, 18 are there, right? So this is an alkane and this one is an alkene. We'll pick another example now. And it's not necessary that whichever I've drawn should be the answer of that. It's an open-ended question actually, unless they ask you to work for that. For example, sometime the examiner will ask you make 2 alkanes and 1 alkene out of, I'm giving the same example, C18. Out of that, make 2 alkanes and 1 alkene. So when I'm making 2 alkanes, I have 8 carbons with me. I'll pick C2H, I'm making an alkane. It will be 6. This is 1 alkane. How many carbon and hydrogen are still left with me? 2 of the carbon are gone. I still have 6 carbons with me.
12 now.
Right? Okay. So if I make another alkane by C3 and H8, so total of 5 carbons are gone, and total of how many hydrogens are gone? 14.
So 14 I got.
So I still have 3 of the carbons in my hand. So plus C3H how much? I've done an alkane, another alkane, and now alkene.
So H6.
If I make it H6, will that work?
No, sir.
No,
It will
sir.
exceed it.
This will not work. Okay, but I'm still left with 3 of the carbons and 4 of the hydrogen. So I need to see whether I can make something like out of these three. Okay, 1 carbon, 2 carbon. It's not the part of the course. Keep in mind what I'm drawing right now, this part. 3 carbons are there. It's an alkene. There's a double bond, right? If I put another double bond here, and I see now the hydrogens, satisfy every carbon with 4 bonds. 1, 2, 3, 4, 1, 2, 3, 4, and this one already satisfied. So I have a hydrogen, a hydrogen, a hydrogen, and a hydrogen here. It can be C3H4, but this will not be an alkene. This will be a diene. Okay, a little bit higher than the course. But there are probabilities which the examiner, and there will be a case where you can make the same example can be modified into 2 alkanes like in another way. If you're not going for this, we'll take another example. The same carbon I'm taking, I'll make 2 alkanes molecules and 1 alkene molecule. Let's take in this way. C3H8 or C2, let us make C2. C2H6. This is an alkane, right? If I double it,
Yes.
how many carbons are gone? 4 carbons are gone, but I made 2 molecules of an alkane. Single alkane, but 2 molecules. So I'm still left with C4, H, how much? 4 carbons are gone, 12 of the hydrogens are gone.
Sir, 6.
So I'm still left with 6, but 4 twos are 8. If I make it 6, then it will not again be an alkane. It will be something different. And let us see what will this look like. C, single C, single C, and single C, 4 carbons. Okay. If it could have been an alkene, there should have been 2 more hydrogens in it. It means there's a triple bond involved in it. 1, 2, 3, 4, 5. This is an extra bond now. Yeah, this bond is an extra one. 1 line here and 1 line here. So you can see 1, 2, 3, 4, 5. 5 are here. 1, 2, 3,
Sir,
4,
can
5,
you
and 6.
scroll to the
Right?
Sir, can you scroll a bit to the right side?
Actually, the scrolling is not possible. In that, I'll redraw this again. Okay. I'll draw this structure. This will be an alkyne then. Okay. C1, 2, 3, and 4. Triple bond. 1, 2. Hydrogen 1, 2, 3, 4, 5, and 6. So instead of an alkene, we got an alkyne here. But again, that's not the part of your course. He will ask you to break it down. So this is a kind of error and trial method where you're going to try and to make different kind of products. So we'll try to make another kind of product out of it. It's all cracking, breaking down the large alkane into smaller alkene and an alkane. So if I pick up C5H10, is this an alkene or alkane?
Sir, an alkene.
This is an alkene.
Alkene.
And how many hydrogens are left and how many carbons are left? C3 and H8. So exactly you can count the number of carbon and hydrogen. These are the carbons, which are 8 now, and look at the hydrogens. 10 plus 8, 18, and you got 18. They can ask you to break it down and to name it. Okay? It can be catalytic cracking or it can be thermal. Right? And can someone tell me the conditions? What was the condition needed for cracking purpose? Last time we had a little bit of discussion about it. Yes.
Sir, a temperature of around 600 to 700 degrees Celsius.
And
High pressure.
and Al2O3 as a catalyst. Okay? So we can use these conditions
Okay, sir.
for the cracking purpose. Let me take another example for cracking. Okay? Now, keep in mind this is the exam question which I'm taking right now. The examiner will be asking you this question very, very, frequently. This is there in the paper. It doesn't follow the definition. If I take an alkane, this is a smaller alkane, but it's going through cracking process, C2H6. What are the possible products? The common mistake which people are doing, which students are doing, let me show you that. They make an alkane first of all, okay? And how do they make the alkane? If it is CH4, one of the alkane, what about the alkene then? Can we make an alkene? Because we are left
No,
with,
sir, we cannot make an alkene.
we are left with one carbon and we are left with 2 hydrogen. This cannot be an alkene. No. So what can we make out of it? What will be the answer for this? So the answer is very simple. When you see that they give you this one and they ask you for the cracking, there will be a C double bond C, an alkene, and a hydrogen will be released out. Instead of alkane, hydrogen will be released out. So it will have an alkene possibility is there, but alkane will not be there. It will be hydrogen. Right? So this is the only probability. So what I mean to say by this is that when you are making two products, both the products should exist. Yani this alkene is existing and hydrogen is also existing. But if I make CH4, okay, CH4 is existing, yes. But what about CH2? No. So that's why this part is wrong. And the correct part is this one. You got my point?
Yes, sir.
This is an exam question and all the time the examiner is asking this question. If you have any question, you can ask about it now. You have any question?
No, sir.
Okay, we'll pick up another example. Let me take C5H12. What's the name of this?
Alkene or butane.
Butane.
No, sir, pentane.
Very good. This is pentane. This is the correct name. Why it is pentane? Because 5
carbon.
carbons are there. So let us take this example now of pentane. and let us make two products out of it. Okay, and the two products are C3H6 and the other one is C2H6. This is alkene,
Alkane and alkene.
this is alkene, and this one is alkane.
Alkane.
So there is no such problem. You can write the alkane first and the alkene then second, followed by it. Okay. If I want to make two alkenes out of it, so what will be the probability? See this now. I'm making two alkenes out of it. This was an alkane, but this will become an alkene now. And along with that, there will be release of hydrogen also. So someone can do like this: C2H4, which is an alkene, and H2 is released out. Clear? So you got two alkenes, along with it one hydrogen. Okay?
Okay, sir. Okay, sir.
It depends. Okay, so that's why it's an open sort of question. So keep that in your mind. Whenever there's a cracking purpose, there is cracking. Why do we do cracking, by the way? Cracking is important to get smaller fractions of the hydrocarbons because they are in great demand, they are easy to combust, they release a huge amount of energy, they can be easily stored, and all the car engines, they are nearly working on these small hydrocarbons. So they are in great need. That's why we want them to be ready for it. They are eco-friendly as well. They releases less amount of carbon dioxide because the number of carbons are less in them. You have any question? Any question?
Mm,
No, sir.